Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Welcome, welcome. Thanks for joining me. We have another video on the go. And if you remember, then you should know that we're busy with image classifications. In this case, I'm doing image classification for my region of interest using Landsat 2. And I think, if I can remember correct, the Landsat 2 image is from September 2024. Yeah, I think from September 2024. So we've used various plugins within QGIS to generate the image classification using our training samples, etc. etc. Anyway, they are all available in my YouTube channel. If you go to View of Space, let me quickly go there. If you go to View of Space, there's the channel. If you go to videos, you'll find they are all basically located here. Okay, so there they are. There's a whole lot of them. We started with pixel-based, and now we went to object-based image classification. So they're all there. So please press those buttons, join, like, share, subscribe. That would mean a lot to me. So yeah, go for it, please. So in the previous video, the last one that we made on the topic, 205 object-based with vector classifier, we basically generated a couple of object-based image classifications. And we used, for example, the artificial neural network classifier. We used the DT, decision tree classifier, and we used the Bayes classifier, and the random forest classifier. So we used 4 of them. And you'll see each one, they're all a little bit different, as you could see. They're all a little bit different in terms of the actual classification itself. Nonetheless, we used those 4 classifiers or 4 methods. And I said it's within the OTB toolbox here. If you go to OTB on your right-hand side, you go to image learning. You see there's the train vector classifier where you train, and here's your actual classifier itself. So if you go into the train vector, you'll see that there is the different classifiers or the different algorithm. As I said, we use the decision tree, we use the artificial neural network, we use the random forest, and we use the Bayes classifiers. So that's the 4 classifiers that we use within our object-based classifier. And they generate significantly different classifications. For example, there's the artificial neural network classifier. There's the random forest. I can't remember which one I've selected, but anyway, there is one. You'll see these values behind us, just the different permutations of the various attributes or functions that you can choose. There's the Bayes, and then we did also let me just untick those ones. We also did a decision tree. There's the decision tree one. You'll see from the decision tree one, if you look at the various ones that we've generated, there is definitely some differences between them. So it's about fine-tuning. So if we go again into our vector, if we choose decision tree, then you'll see there is various options that becomes available. So, for example, the depth of the tree, the number of samples, etc., etc. So these values here are basically variations around the default settings within that specific classifier. So you have to play around with them, and I think I've selected this specific one. So nonetheless, we have 4, but these ones, as you can see now, they are in vector format. Okay, so if I go properties, you'll see they are in information, they are in vector shape. Okay, SHP. Okay, so they are vector shape. Whereas our pixel-based image classified images, there's one. If you can vaguely remember, there's another one. There's another one. There's another one. They are all in raster format. So what we need to do, we need to take our selected classified images for each of our preferred. I'm just quickly want to see which one did we do here. Is it this one or is it that one? Okay, so I think it's that one and the base. So that's the 4 that we've that I've selected from our object-based classifications. So what we have to do is we have to convert these 4 into these 4 vector files. We have to rasterize it. We have to convert it into raster files. Okay, so now what is important first is that we have to get the pixel sizes as close as possible to the pixel sizes of our rasters, classified rasters. Okay, so our extent has to be as close as possible, and you'll see what I mean now. Okay, so first of all, we need to get to what is the pixel size, what is the extent of our raster images. These raster images that we have generated, these ones here. What is the extent of them? And they're going to be all our raster images all the same because they are using the same raster. They're using the same, sorry, not raster, they're using the same stack raster of our Sentinel bands. So they're going to be all the same. So it doesn't matter. So you can go to any of these ones. So let's click some, where is it? Let's click this one that we have now. We're going to go properties and we're going to go information, and you'll see here it says the pixel size 124 and minus 124. So just copy that. So that's important numbers that we have to do, because you're going to see when we're going to rasterize, it's going to ask for this. So just copy this and we're going to say cancel, and then we're going to go to our vectors that we want to rasterize. So let's take this one for now. We're going to go to raster. We're going to go conversion. We're going to say we want to go from the vector to the raster. So this is the one, the segmentation. Make sure it's the correct version. Now, obviously, the field that we want to burn is important, and that is our predicted field. You'll see that is the 1, 2, 3, 4, whatever the allocation is for each of these segments. Then here is an important one. Okay, this is very, 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 very important. Here, we're not going to go for pixels. We're going to go georeference units. Okay, so this is very, very important. So please don't choose the other one. The pixels, use the geographic ones. Okay, so this is very, very, very important. Okay, now this is where those values needs to be entered in. Okay, so the width, so just paste it in and then delete the latter part of it, cut that one. Come on, we're gonna put that in and we're gonna just take that one out. Cut. Sorry, so let's quickly just open a little Word document where we can paste that in. And I'm just going to take the front one and I'm going to copy that. and I'm going to paste it in here, but with the comma. And we're going to make that a comma. And then here, it is exactly the same. You ignore the minus. It automatically understands that the height is the minus the vertical. Okay, so again, come on, there's the numbers. You'll see it's basically exactly the same, although this one is a little bit different. So let's rather copy that. And I said ignore the minus sign. Don't worry about the minus sign. It automatically understands it's a minus, and then change the point into a comma. So this is very, very important that you understand that you have to do. Okay, so please remember to do that. As I said, please make sure that this is georeference units, and the width and the height is the same as with our rasterized image classifications. So that's important. Don't worry too about the extent. If you want to, you can do this, but that's not really a crisis. The no data is not an issue as well. So just to summarize, it is the vector file that you want to rasterize. It is the value within that file that you want to rasterize. It's the reference units. And then the width and the height is the values as it pertains to the raster images that we have. And then we're going to say, I'm not going to save it because I already saved it. But let's just for interest sake, I'm going to position it there, and we're going to say run. Don't worry about all these other things. It is that 0 values that it's going to put in. And there it is. It is now, it has rasterized that file, and you'll see there's pixel values 1 to value 6. Now it's just a matter of going into properties, going to symbology. Then in symbology, we're going to go to unique values, and I've already saved the style. So I'm just going to go into a save style. I've already saved it. Let me just, there it is, and open it and load my style. You'll see it will load it 1 to 6, and you just press OK, and there it is. And now this specific raster file is an object-based image classification of my region of interest using the decision tree with all these values. It's not the default values, these specific values based on our segmentation that we've done. Okay, and I said now we can compare, and we do it for all of those 4, and then we have it. And then you see if we right click, go to properties, and we go to information, you'll see there it is. And now that extent should be exactly the same as my other values. You see. Okay, so this one obviously looks a little bit different because it is the segments. Okay, but it is the same extent, same everything as my raster values. Now it's comparable. So I've already done that. So if I'm going to remove that, you'll see there is my artificial neural network image classified image in raster format. There's my decision tree, the one that we just did. Classified image in raster format, and let's move it that way. And there is my random forest, and there is the base. There they are. So there's all 4 of them, the image, the object-based classified images in raster format. Remember, it's going through that whole process of object-based image classification. Okay, so now I've done all of the classifications that I wanted to do using all the different. So let's quickly go to my spreadsheet. And then remember, we started with the Tsaka plugin, and within Tsaka we use the Gaussian, the K nearest neighbors, support vector machine, and random forest methods within that specific plugin. Then we use the classifier plugin. Within the classifier plugin, remember this is I don't go into the the detail of the classifiers or algorithm, meaning the characteristics or attributes of them. In many cases, I didn't use the default settings. I used different settings, but as I said, I don't go into the details of that here. Here is in the classifier, I use the minimum distance, I use the k-nearest, I use the support vector, and again, the random forest, very similar, except the Gaussian and the minimum distance. Interestingly, you can see the differences. So in theoretically the same algorithm, but in different plugins, you get significantly different outcomes. Then we use the classification plugin. Then we use the neural network plugin. Then we use the OTB, but the pixel-based, not the object-based. There they are. And then we use the semi-classification plugin. We use those three algorithms. And then what I've done here is I've basically just calculated the average of them all. You'll see there's the averages. Because theoretically, the average should be the closest approximation of the actual classification. Okay, and there is the averages. So the average pixel count for class 1, which is water, is 4,000 pixels, 63 million square meters. For 2, which is felt, is 162 pixels, etc., etc. So that is calculating the average of them all. And if I just calculate each of these pixels as an average, as a percentage of the total, you see that according to the average pixel-based image classifications of all these classified images, then water accounts for 1% of my region of interest, veld almost 40%, the mountain almost 15%, farming 29%, urban 8.5%, and sand 6.6%. So that is the percentage that each of these land use or land classes accounts for the total surface area of my region of interest. And as I said, these values are based on the average number of pixels and average area based on all these individual classified images. Okay, so that is the pixel based. That's all. And then we obviously did the object based pixel object-based classifications. And again, as I said, we use the artificial neural network, decision trees, random forest, and the base. And there is its allocations or its pixel counts. So in this case, again, I calculated the average. So based on the object base, there was 5,097 pixels for water. In the pixel base, there was 4,000. So there's 1,000 difference there. In veld, there was 174, and here's 162. In mountain, it's 59,000, so that's virtually the same. In agriculture, it's 99,000, 108,000. Urban 34 and 34, so the urban is very, very similar. And then water is 33 and 26, not that dissimilar. So there is differences between the two, object-based and pixel-based, but in the main, they're roughly in the same. It's not like the one says this one is the most, and the other one says, no, that one is actually the least. This one is the most. So if we compare the two, you'll see that with the pixel-based, and this one is object-based, you'll find that in pixel-based, it suggests that 1% of the region of interest is water. Object-based 1.25%. Veld pixel-based is 39. Object-based 42%. Mountain is 14. Mountain is 14. Farming pixel-based is 29%. Object-based is 24%. Urban is 8.5%. Pixel-based, object-based is 8.5%, sand is 6.6%, and object base 8.34%. So they're actually quite similar. They're not that different from one another, which is quite an interesting debate in terms of what is more accurate, object-based classifiers or um, object-based classifiers. Anyway, maybe just put it in a nice graph. And you'll see they're very close. If you'll find correlation, let's quickly say what the correlation was, probably be very close to 1, I would venture to say. So let's do this one. It's very, very small sample of, so it's most probably not going to give very nice, but you see it's almost a perfect correlation between the two, which is very interesting. I would expect it to be a little bit different, wider. Now, again, this is averages, so it cancels the outliers, etc., etc., etc. That's what I'm saying. Theoretically, the average should be the most accurate image classification. Okay, but so we can now obviously compare each of the individual classifiers, classified images to the actual to the average, and then we can see which one of them performs the best. So that we can do as well. So for example, where did we do that? So in this case, what I've basically done here is for each of my plugins and each of my methods, I've copied and pasted the pixel, the number of pixels for each of these classes. So you'll see if I go into the Gaussian, you'll see there's 177, K is 4471, and you'll see there 177. Why is it 88? Felt data. Yeah, there's 8854. So it's below one another. You see there's 447, etc., etc. So I just basically copied. I didn't work out the area because they basically the same thing. So I just used the pixel count values. I just copied and pasted all these values into this column. Okay, so you'll see there they all are. So there's 23 of them. There's 23 of them. This is all the pixel counts as derived. And I've calculated the mean one, which is 3981. If I go back there, you'll see the mean one is slightly different because in this case, I also calculated the means of these ones. So in here, I've excluded those values there. So let's argument's sake, these are the values of my mean. Come on. Now, obviously, I can compare each of these methods in terms of the mean, meaning where's the variation between the mean value and these actual values the least. Okay. And so what I do is I delete. Okay, so let me just quickly go and I just want to quickly copy this because this is another value here. So let's quickly take is equal to that value there. And then I drag it to the right. So this is the mean value. Okay. We can also use the median value. That's up to you. We can do both. But there's the mean value there. That's the mean value there. You'll see that value, and that's the average or the mean value of all of them. Okay. And then you'll see the Gaussian, the water, the actual the difference between the actual count and the mean count is that value. Okay, so that's quite large. So now we can rate them. So I'll just say rank each one. Obviously, we want the value to be the lowest, which looks like it's that way. No, there's the value. That's the lowest. So the Jetsaka random forest classified image water count is virtually the same as the average. So if you go to there, you see 3298, which is, and this is 3, another Jetsaka, there's it 3972, and this is 3981. That gives you a difference. So this would be from a water point, this one is the closest. And you see there it is. So I've ranked them. Okay, so these are the ranks then in terms of the best. And this is the rank. So that's the average rank of them all. And this is the average rank in rank format. And in this case, it says that the classification plugin, the KNN ball tree algorithm within the classification plugin performed the best in terms of its classified image compared to the average classified image. Okay, so you'll see that's the first one. That's the most accurate one. Then you'll see the Dechaka random forest. So this interesting is a KNN ball tree. That's the Dechaka random forest. And where's number 3? It is the SCP multi-layer perceptron algorithm. So there's it. So now, which is the worst one? The worst one is the So the classifiers got the best one. The classifiers got the worst one. Where is 23? Then, sorry, the neural network, identity 20 neutrals is the worst, followed by the classifier support vector machine, followed by the Dechaka Gaussian method. So now we can rate them. Okay, I can obviously sort them from 1 to 23, but you get the picture. So this gives you indication that from this is now the pixel based. Now this is not the object based. There's the object based. Let's quickly do the object based. Let me just quickly take that value again, copy it, paste it there, and then just says equal mean. And we're going to do it. Drag it to the right. And within this case, it is the random forest model, which is the best. And then it's a toss-up between the ANN, the artificial neural network, and decision tree, with Bayes coming last. Yeah, now just intersecting, remember, let's quickly just highlight this one. I was going to see, I'm just going to quickly highlight this one. And then the worst one is this one. So let's quickly give that value. So what I want to do is just see if I use the median value, not the mean. If I use the median value, because I actually like the median statistic more than the mean statistic because of this outlier issue. Let's have a look and see. So now it changes. So now the O2B KNN is the best. So the ball tree, the classification ball tree, went from the first position to, oh no, it still stays the first. Okay, so that still stays the first. And now the neural network one is not the worst anymore, but it's the second worst. So there's slight difference. But we have to further investigate that specific one. So that's one method of actually assessing and evaluating all our different classified images. Okay, is by comparing each actual counts with the average or the median count of them all, and then just ranking them, etc., based on the differences, absolute differences. This is not the, yeah, so it's absolute. You'll see the formula is the absolute difference. We're ignoring the minuses. And then we rank them, and then we can see which one is the best, which one is the worst. So that's possible to do. Okay, so that's one way of assessing, evaluating the individual classified images, meaning the plugins and their algorithms. Another way, obviously, is to use the SCP doc. And if you see it in post-processing, there's an accuracy option. Now, obviously, we can use this one option. And I did do that in the past. maybe I'll do one again, but basically we can use this function. Now, what it does, it generates an output report, and in the output report, it gives you the overall accuracy and the kappa hat classification of each of these classified images. Okay, so if we go to pixel based, so the Zaka Gaussian, then according to the SCP doc, it has an overall accuracy of 41 and a kappa hat classification as 0.39. So we obviously want these values to be as high as possible. So I've generated a report for each of this 23 classified images, and now we can go and see where is the highest. So in this case, the OTB KNN is the highest. Okay, and again, we can take this one now. This is this value here, and we can copy that and say, listen, let's write that. Let's write each of these individual classified images now in comparison to that particular one, not the mean or the medium of the all now, but that particular one, which is according to the SCP doc, the best option, because it's for 84%. You'll see there's nothing higher than that. Then we can go write them again, and you'll see now the ball tree, which was the highest, is now the 7th. And the neural network, which was the worst, is still the worst. The highest now is obviously the KNN, which we've just used now. And we can do the same for the object-based. We can use the same for the object-based, which is according to the object-based. The base one is, because remember, now if you look in the averages, the base is the worst. If you use the so interestingly, if we use the average method, base is the worst. But if we use the SCP doc, then base is the best. So that's quite interesting. So if we use the base values as the baseline, we paste it in, then obviously it's going to be the best. Followed by either the decision tree or the random forest, and in this case the artificial neural network is the worst. So there's two ways of three ways of evaluating the classified images. One is to use the mean value, the other one is to use the median value, and the third one is to use the SCP doc post accuracy assessment. This one here, which is in the post-processing functionality. There's the accuracy assessment. We can use that as well. So there's three ways, and it's just in this case, obviously the mean and median doesn't show too little difference in the rankings, but it seems to be quite different when it comes to the SCP doc. So if we then compare the two with one another, you'll find that so let's quickly just see how they differ with one another. So here's the base. I'm just going to do the base. Did I do that? Nope. Let's just quickly do the base here. Let's do it in here. So that's the base, and the pixel base, it's a KNN. Which one is it again? OTB KNN. OTB KNN. Is it this one here? Let's just make sure. OTB KNN, data OTB KNN. So let's just quickly take this one here. So according to the pixel based this one is the best performing. So let's compare them. 392 and this one, 131, 860. So there's quite a big difference. Yeah, so now there's quite a big difference. So the base, huge amount of sand compared to the KNN. So we can also now go back into our, so there is the base, which is rated the best according to the object-based method. And then the KNN, where is it? OTB, KNN, OTB, OTB. There's KNN. There it is. So there's the OTB KNN classified image, and there's the base classified. So according to the object-based method, this one is the best classified image of my region of interest. According to the pixel-based, this one is the best image. Now, yeah, visually, both of them seems fairly rubbish to me, to be very honest. As I said, visually these two doesn't, it doesn't, I can't understand why they are rated the best, but they are rated the best. So for example, this one, for example, to me looks much better um, compared to this one. There's just way too much red, but I may be biased in the sense that I'm looking at the red and forget about the other 5. So the red could be basically wrong, but the other 5 could be very accurate. So I'm just very, maybe I'm just biased because I'm looking for the red, and the red shouldn't be that much. But yeah, so that could be could be the reason why I'm not too I don't necessarily agree with those rankings and stuff. Maybe a little bit more work needed. Who knows? As I said, I'm sure these ratings are, and then we'll have to do the sensitivity analysis of these ones. For example, if we change the settings, as I said, in many cases, I've used the settings on my visual interpretation. I said, maybe my visual interpretation has been terrible, and therefore the actual settings that I've used is terrible. And maybe we'll have to redo this. But yeah, it's a fascinating and interesting study. As I said, it's something that let's quickly do that. It's something that needs further work. Let's quickly do that. And this one there, I'm going to insert and put it that. You'll see that water is very similar. Veld is very similar. And agriculture is very similar. The difference is in the mountain and the sand. That seems to be the differences. And urban is very similar. So it's struggled to differentiate between the two. So if you look at it in that sense, maybe it's okay. I don't know. It just visually doesn't look proper to me, doesn't look right to me. Anyway, so this, I think, if you go into what we set out to do when we started this series, you'll see there we started it, and that 180, when we started it, this was the whole purpose, is to use all of the tools within QGIS to do image classifications using a standard, my region of interest, a standard Sentinel 2 image, using the same training samples, the train assessment samples, and then to evaluate, or to just first of all go through each of these methods, and then to assess these methods and to see which one is good and which one is bad. So we've come full circle in that we've got a winner. In my mind, there's still some work that needs to be done, but we have a winner. So from a pixel-based, the KNN in the OTP is the winner, and from object-based, the base in the OTP is the winner. So in fact, both are OTP plugins. You see there's the OTB plugins and there's the OTB. So in both cases, the OTB, Ethereal Toolbox, a plugin is superior. From a pixel-based, the KNN method is superior. Object-based, the base method is superior. When we use this semi-classification plugin assessment method or tool. And overall, the base gives you the most accurate classified image between object-based and pixel-based. So that is the conclusion of this weeks and weeks and weeks of work and stuff. So hopefully that will help you and assist you when you do your image classifications in terms of where you should start first, which one should get priority, etc., etc. Now, as again, it all depends. There's so many variables that influence this. Your region of interest will influence this. The actual image, stack raster image. And I say if I do this in a different month, everything will be different. So in this case, I said, that's why I said September. If I change my training samples, my assessment samples, all of these things will change. So these values are very, very sensitive. So please bear that in mind, that this is for my particular situation, given the base images and values that I've used. Okay, so with that said, thank you very much for attending. Now we're off to our next series of remote sensing and Earth Engine, QGIS, RStudio, Geoda, Excel. We'll see what we're going to do next. I haven't got something on my mind as yet, but we'll figure something out. Yeah, we'll definitely figure something out. So yeah, go and enjoy the videos, like them, subscribe, share them. Your support means a world to me. And then I'll see you on the other side.